Good morning, dear students, and welcome back after a break. I believe that you had a wonderful time. You also have completed your notes and assignments. Since we are continuing with online video lectures, so I request you to kindly attend the video lessons regularly and complete assignments on time. If you do have any doubt, kindly message on Campus Care for clarification. In chemistry, we already have started with lesson 3, atoms and molecules. We discussed that what an atom is. Atom can be defined as the smallest particle of matter that takes part in a chemical reaction. As we discuss how big are the atoms, atoms are very small and they even are smaller than anything that we observe around us. A few characteristics of atoms include: an atom is the smallest particle of matter. All elements are made up of tiny particles called atom. Atoms are very small in size and cannot be seen through naked eyes. Atoms does not exist in free state in nature, but atoms take part in chemical reaction. The properties of matter depend upon the characteristics of atoms. Atoms are the building block of an element, similar to a brick which combine together to make a building. The size of atoms is indicated by its radius. In ancient time, atoms was considered indivisible. John Dalton, a English chemist, meteorologist, and physicist, best known for his pioneering work in the development of modern atomic theory and his research into color blindness, gave the characteristics and properties of atom through his atomic model. We call this atomic model as Dalton's atomic model. His postulates were based on the experimentation, which are actually based on laws of chemical combination. We already had seen main postulates of Dalton's atomic theory, which are as follows. Elements are made up of extremely small particles called atoms. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form chemical compounds, and in chemical reactions, atoms are combined, separated, or rearranged. These atoms of different elements are represented by symbols. Symbols of some elements are formed from first letter of the name and a letter appearing later in the name. Like for example, the element carbon and its atom is represented by C. Element oxygen and the atom of it is represented by O. Nitrogen, the atom is represented by N, whereas chlorine is represented Cl, an atom of zinc is represented by Zn, etc. Some have been taken from the names of elements in Latin, German, or Greek. Like for example, an atom of iron is represented by Fe as its symbol, which is from its name ferrum. An atom of sodium is represented as Na from its Latin name natrium. An atom of potassium is represented by K from its Latin name kalium. Laws of chemical combination, which help Dalton to give the characteristics and the properties of atom, are basically of three types. Law of conservation of mass. This we already have had discussed before vacation. Lavoisier, a French chemist, established the theory of law of conservation of mass on the basis of the experiments Dalton had performed. The law of conservation of mass states mass can neither be created nor destroyed in a chemical reaction. So, according to this law, mass of an isolated system will remain constant over time. This means when mass is enclosed in a system and none is allowed in it or out, its quantity will never change. That is, mass will be conserved, and hence this is called law of conservation of mass. This means total mass of products is always equals to the total mass of reactants, as there is no loss of mass of substances. That is, mass is conserved. That is why Lavoisier called this as the law of conservation of mass. Here, the reactants and products are involved in a chemical reaction, which include the substances that combine or react are known as reactants. The new substance or substances formed after the change are called product or products. Let us take the example. When calcium oxide is dissolved in water, calcium hydroxide is formed. The reaction involved in this can be represented as calcium oxide plus water gives calcium hydroxide. These two are the reactants, whereas we do have a single product, calcium hydroxide. In this reaction, calcium oxide and water are reactants, and while calcium hydroxide is the product, we can say that if measured or weighed the quantity, 74 gram of calcium hydroxide is obtained when 56 gram of calcium oxide reacts with 18 gram of water, which is proved by experiment. Here the total mass of reactants, that is of calcium oxide and water, is equal to 74 gram, and the mass of the product, that is calcium hydroxide, is also equal to 74 gram. This proves that the total mass of reactant is always equals to the total mass of the product. No such creation of mass or destruction of mass has occurred, which proves the law of conservation of mass. Today, we will see the two other laws of chemical combination. This is law of constant proportion. Law of constant proportion states that a chemical compound always contains exactly the same proportion of elements by mass. This law is also known as law of definite proportion. Joseph Louis Proust gave this law, hence this is also known as Proust definite proportion of chemical reactions. He analyzed the chemical combination and chemical composition of a large number of compounds and came to the conclusion that the proportion of each element in a compound is constant, that is fixed. Based on these observations, he formulated the law. He further had given a n number of examples to prove this. Compounds are formed by combination of two or more elements. In a compound, the ratio of atoms or elements by mass remains always same irrespective of the source of the compound. This means a certain compound always formed by the combination of atoms in the same ratio by mass. If the ratio of mass of constituent atoms will be altered, then the new compound will be formed. Like for example, we know that water is a compound. If we decompose 100 grams of pure water by passing electricity, then 11 grams of hydrogen and 89 grams of oxygen are obtained. Now, if we repeat this experiment by taking pure water from different sources like river, sea, well, or of ice, polar ice caps, etc., the same masses of hydrogen and oxygen elements are obtained in each case. This experiment shows that water always consists of the same two elements, hydrogen and oxygen, combined together in the same constant proportion of mass, 11:89 or 1:8 by mass. And this is the law of constant proportions or the law of definite proportion. We can take up the example of ammonia also. The compound is formed as a result of combination of two elements, nitrogen and hydrogen, every time. The two elements combine together in the same ratio of 14:3 by mass. Common salt, which is sodium chloride, also is formed of two elements, sodium and chlorine. If we will consider the masses of the two elements in the compound, it will be always 23:35.5. Carbon dioxide gas is formed as a result of combustion of various substances. The gas is a compound and is formed of carbon and oxygen, which has the masses in the ratio 3:8. Calcium oxide is a compound of calcium and oxygen where the elements are in the ratio 5:2 by mass. Finally, in magnesium sulfide, the same, the ratio is 3:4. The third law of chemical combination is law of multiple proportions or law of variable proportion. The law states that the mass of one element that combines with a fixed mass of the other element are in the ratio of small whole numbers if two elements are combined to form more than one compound. Like for example, the two elements carbon and oxygen, when combined, can form two compounds which are carbon dioxide and carbon monoxide respectively. Compounds of differing mass ratios of the same elements are found, but they will also have different properties. If we consider carbon dioxide gas, it is used for the process of photosynthesis by green plants. The gas is considered as one of the good example of fire extinguisher, whereas carbon monoxide is very toxic. It is fatal for human beings and is not used for the purpose of photosynthesis by green plants. Elements combine together to form compounds, and if we consider hydrogen and oxygen, these combine to give water. However, water is not the only product resulting from a combination of two elements. The two elements can also combine to form hydrogen peroxide. When we consider water, the formula is H2O. The particular elements are in the ratio of 1:8 by mass, whereas the formula of hydrogen peroxide is H2O2. Atoms are increased in the compound Therefore, the two elements will not have the same ratio by mass like of water. So we can say by third law, law of variable proportion or law of multiple proportion, if an element is 1 which combines with element 2 gives compound 1. The same element 1 when combines with element 2 can give compound 2. Here the ratio of atoms of elements will change and so their masses. There are many such cases where two elements can have multiple products on combination, such as methane, ethane, propane, butane, pentane, ethene, propene, butene, pentene, ethyne, propyne, butane, pentine. These compounds are of carbon and hydrogen, also known as hydrocarbons, but each and every compound differs in the ratio of atoms by their masses and the ratio of atoms also. So today we discussed law of definite composition or proportion, where a given compound always contains the same fixed ratio of elements, and law of multiple proportions, where elements can combine in different ratios to form different compounds. So if we have to state the law of definite proportions, law of conservation of mass, and law of multiple proportion, we can say that each sample of a given compound contains the same elements in the same proportions by mass, regardless of the size or source of the sample. Then this proves law of definite proportions. When the mass is neither created nor destroyed during a chemical reaction, and the total mass of a product is always equals to the total mass of the reactants, then this is law of conservation of mass. When the same elements combine to form different compounds, they do so in different ratios that can be expressed by the mass or whole numbers of their, then this is law of multiple or variable proportion. Based on these laws of chemical combination, we will see a few numericals based on this as your assignment. And in our next class, we will start with other properties of atoms which help us to know their mass and also the particular involvement to form the molecules in compound. Thank you.